All right, hello everyone, and welcome back to our live coding series where we learn how to write React applications using the ReasonML programming language. In the previous episode, we saw how we can write a static React application, and what we will be doing in today's session is add the reactivity to the mixed. So what we will be doing is making our to-dos completable so we can edit and change the completed state of our to-dos. So this is the first thing that we will see in today's session. And the second thing that we are going to see is that or how we actually can get rid of undefined problems. And we'll see the secret behind this. So just like all of the episodes, to be able to follow and program with me, I will share with you the link of the repo, and you just need to go to the tag EP3 to be able to program with me. So I'm going to share the program with you, the repo with you. Okay, so there's the repo. Just let me make sure everything is fine. Okay. So let's start right where we left off in the previous episode. And I just want to remind you guys of the what are they called? Yeah, of the commands that we use to compile our program and to run our dev server. So this is the command we use to compile our program. And this is the command that we are going to run to launch our dev server. Okay, so everything is hopefully going well. We are going to need to wait a little bit for our program to compile, I believe. Yes, so here it is, and everything is working. So let's launch our editor, and let's open our app file, and let's see how we are going to implement reactivity. So the thing is, we are going to actually use the use reducer hook. So if you are used to developing React programs in JavaScript, you might not use the use reducer hook that much, but this is what we are going to use when using Reason, because it actually makes it because it's actually easier to use the use reducer hook, and it helps us have better control over the actions that can happen in our application. So just like in our previous episode where we saw or where we had to think about the type of our to-do, we'll have to think about the type of the state of our application. So let's define a type for our state. And actually, this is going to be a simple one, because it will just be, we will have only one property of to-dos called to-dos, and the type will be actually a list of to-dos. So this is going to be our state. Now we want to think about our actions. And actually, we are going to see where the actions and the action creators that you see or use in typically Redux applications. We will see their origins, where they come from, and why people or the Redux library tells you to use action creators. So let's define the type of our action. So our action can actually be, and this is how we define our action. So it can be either toggle complete of a to-do, and actually here we are going to define the payload of our toggle complete, so it will take an integer. Why is that? Because we are actually expecting to receive the ID of the to-do that we want to toggle. And let's say, for example, we have another action, which is resetting our to-dos to their original state. So now we have our state and we have our action. And what we did here actually is that we defined both the types of our actions, we defined the payload of every action, and also at the same time, we defined our action creators. And you're going to see why is that. So let's write our reducer function. So what is a reducer function? It's simply a function that takes a state and an action and returns a new state depending on the action that we received, and eventually the payload of that action if it has a payload. So let's define our reducer function. So it will be a reducer. Let's say it takes a state and it takes an action. As you can see, again, we do not really write that many type annotations, so we did not write the type of the state or the action. So now we are going to switch over our action, right? So if our action is a toggle complete, and let's say, for example, I forget about the payload, and I'm just going to go ahead and return the state, actually we get a compile time error, and right away the compiler is telling us that the toggle complete is actually, as you can read here, it's expecting one argument, but it received none. So we need to fix this error by adding our payload. So let's ignore the warning for now and just do what we need to do. So what we receive a toggle complete, so we are going to return a new state, which is going to be a to-dos. And what we are going to do is take the previous to-dos and toggle the one with the ID that we received. So it will be the state dot to-dos. Are going to pass that to our list dot map function. And we are going to use a function that takes a to-do, and if our ID matches the ID of the to-do in hand, then we are just going to return a new to-do, which is actually we are going to do what is known as a functional update or immutable update. So we use a to-do, and then we update our completed state with the opposite of what we had previously, which is the to-do dot completed. If the IDs do not match, then we just return the to-do and do not return anything. So let's save, and we are actually getting a warning here. And what it's telling us is that this pattern matching, so which expression is called pattern matching. It says this pattern matching is not exhaustive, and here is the case that was not matched, which is reset. And it's talking actually about this action. So what's happening here is that actually the compiler is making sure that we treat all the cases that are possible. And actually, it shows that it is a warning, but I changed some options in the compiler to actually get a compile time error, and our program no longer compiles. So let's fix the error and add the case for a reset. And let's say when we want to reset everything, we are okay. It's to-dos, and we are just going to return the initial to-dos. And here it's telling us that we do not have to-dos, and this is because our to-dos here need to be defined before our reducer. So if we put it in here, just before our reducer, we actually get everything compiling. So let's save. Everything is compiling. And should we check that everything is working? And of course, it's not, because we need to actually connect our to-dos or our state and use the use reducer hook. So let's write our use reducer hook, right? So in the use reducer hook, we receive a state and a dispatch function. And we are going to use the react.useReducer with the reducer that we just wrote above. And for our original state, it will be a to-dos with the static to-dos. And we need to add the semicolon. It's quite important in Reason to add the semicolons. Okay. So what we need to think about now is we do not want to keep mapping over the list of to-dos, which is hard-coded, but we actually want to use the state dot to-dos. So we want to get the to-dos from our state. We can also use the destructuring that you might be familiar with. So we can here write to-dos and remove this, and it's going to be working just fine. So now our application compiles, but it still is not reactive because our to-do components do not dispatch actions yet. So let's see that we want to add a dispatch function to our to-dos. So just as we wrote this the dispatch, we got here a compile time error, and it's telling us that this argument cannot be applied with label dispatch. And remember that our components are functions, and they take props. And as you can see here, our to-do component does not take a dispatch prop. So it's still, the compiler is telling us to add a dispatch prop to our component. Okay. So now we added the dispatch function. So what we are going to do is go to this to our input, to our checkbox, and just implement the onChange function, and it will be a function that takes an argument that we do not care about. And this is what the underscore here means. It means that actually our function takes an argument, but we do not care about that argument. We are not going to use that argument. So on change, what we are going to do is dispatch a toggle complete. And here is the action creator that I told you about. So we did not need to define a new function to write our actions. Actually, we got all of that defined just when we wrote our action type. So here we are going to need to dispatch the complete to-do with the ID of the current to-do. And everything is compiling. Let's check that out. So yes, it said that it's finished compiling. So it's compiling just fine. And now, as you can see here, we can actually change the completed state of our to-dos. So this was a good way to actually add interactivity to our program. And what we are going to do now is actually talk a little bit about how we can get rid of undefined problems. And why am I going to do this right now? Because it's actually related to what we just saw with the type of our action. So as you have seen here, I can actually define a type which can be one of many types. So our action, it can be either a toggle of complete, or it can be a reset, or it can be, if I want to add some other variant to this action, I can add, let's call it new variant, and it's going to work just fine if I follow what the compiler is telling me. And why is this important? Because this introduces us to a concept called variants. And what are variants is the ability to define one of many types. So what you might be used to in, let's say, for example, Java or TypeScript, is that you can define an object to have this property and this property and this property. But you cannot define an object that has this property or this property or this property without adding some booleans, and that actually might not be true to what you to your model, and you can actually start introducing some errors to the way you model your objects. And what this have anything to do with the undefined, right? And the thing is, in Reason, when we have, let's say this title is of type string, it's actually, you are guaranteed 100% that at runtime you will get a string. It will not be undefined, right? So whenever you are acting on this title, or whenever you're accessing this title, you are guaranteed to have a string, and you cannot get property of undefined, or let's say you define a function, you cannot get undefined is not a function. It's just not possible in ReasonML. So you might be thinking, well, sometimes I actually need some properties to be optional, right? And what that means, that sometimes I want, let's say, for example, for our to-dos, I want to have a subtitle, but it's not necessary to have this subtitle, right? So let's add a subtitle here. And its type actually is going to be an option of a string, right? An option of a string. Okay, so actually, the option of a string and string are two different types. And what is an option of string? So an option of string, it can be either, of course, again, here the compiler is telling us that it's even telling us that some record field is not defined, which is the subtitle. So this is just to actually think about it, and it tells us that we can actually trust the compiler when we want to do refactoring. So we can refactor our application and be really confident with our refactoring, because the compiler is actually going to save us all the way through. So here we have the completed, and let's add our subtitle, right? So the way we add an option of a string, so it can be either some, let's say, some string like a subtitle, or I can define it as none, right? And this some subtitle or none is actually, it looks just like our action, right? So it's just like changing this toggle complete with some and changing the reset with none. And the thing is, what's going to happen here, let's say, for example, I want to display my subtitle, but of course, I will not get the subtitle all the time. So what I can do is actually go to my to-do component, and in here, we can add a switch expression. This is also one of the good things about Reason, is that we can just use switch expressions or if expressions inside of our JSX. We do not need ternary operators or anything like that to for it to work. So let's say switch over our to-do dot subtitle. So if we have a subtitle, and this is actually is required to write the switch statement. Otherwise, we cannot access or have access to what's inside of that subtitle. So if we have some string in our subtitle, or let's call it subtitle. So if we have some subtitle, let's say, for example, we are going to return a span with a string element, a React string element with that subtitle. Otherwise, if I have nothing, so let's just return a React dot null, right? Let's add some class names here to make things look a little bit better. So let's add some margin to the left, and let's make the text actually take its base font size. So let's compile this, and it's compiling. We have no errors. If we again go and check, we have no errors. It's compiling. So we can check our application, and actually we have here a subtitle, and we do not have any runtime type errors. And this is the thing about Reason. Actually, it just makes it impossible to hit or to bump into runtime type errors. And you might be thinking, what's the big deal with that? It's because actually most of JavaScript errors or program crashes, they come from these runtime type errors. So when you make runtime type errors become impossible to bump into, you will actually solve a lot of problems without the problem needing to actively check in manually for every access. So by just using the language, we actually save ourselves from bumping into these runtime type errors. So you can really be confident with your refactoring. You can change your types however you want, just like you saw when we added a subtitle. The compiler told us that our in here, let's see, where we added a subtitle to our type, it actually kept telling us the places that we needed to change or to correct in order for our program to compile. And when our program compiles, it actually works just fine. So this is the really big thing, or one of the big reasons why you might want to use ReasonML for your projects, is that you really are just more focused in producing value and in developing features, and you are actually spending most of your time developing and not doing tests and actually running into possibly hitting some or bumping into some runtime type errors. So this is the, I believe this is all that we have for today's session. So we saw how we can add reactivity by using the reducer and the use reducer React hook. And we also saw how variants, we learned about variants, and we saw how they play an important role together with the compiler in actually writing type-safe code that will not give us runtime type errors. So thank you guys for checking in the stream. If you have any questions, do not hesitate. Just leave them in the comment section. I will make sure to read your questions and answer them. Thank you guys for coming in, and see you guys the next week. Bye guys.